Welcome to N is for Networking. Today we are following up on episode 37 on IPsec basics by thinking through, I guess I'm going to call it an IPsec transaction, where you got two network devices and they need to form an IPsec connection, a tunnel, if you will, between the two of them. Now, if you missed episode 37, IPsec is short for IP security, and it is a long-standing protocol suite that is used to make sure that the data you're receiving is coming from the source you think it's coming from, that nobody can read the data if they intercept it, and that no one's changed the data on its way to you. Now, a really common use case for IPsec is to create a virtual private network tunnel between two trusted networks, traversing an untrusted network such as the internet. And similar technologies you might have heard of include SSL VPNs. They're not too popular, I guess, like they were, but WireGuard, that's another one that's come up that you might have heard of as well. That's quite popular here in 2025. Okay, I am Ethan Banks. I am a longtime IT veteran. I got about 30 years of experience and a deep specialty in networking. It's been my jam for a long time. I love it. And with me, as always, is Holly Metlitzky, and she has been in the networking industry for, it's a couple years, right, Holly? Give or take? Yeah. Okay. And you, however, are accumulating certifications and expertise at a fairly frightening rate, if I do say so myself.
Not fast enough.
She nods her head. You have more certs in such a short amount of time, and good for you. Anyway, you can follow Holly and I on LinkedIn and the Packet Pushers community Slack group. And please do packetpushers.net/community. If you want to join that Slack group. There's about 4,000 people in there, and we got all kinds of channels for all kinds of things, whatever you want to talk about. Just hop on in, ask a question, or share your knowledge if you got a lot going on in your own world and are willing to share with the community. It'd be great. Now, before we start our IPsec discussion today, Holly and I received some listener follow-up from you nice people, and you can send your thoughts, follow-ups, and any comments that you might have to us via packetpushers.net/follow-up. And thank you for doing so. Holly, why don't you share comment 1 from Anonymous, which was a very nice comment.
Yeah, I love seeing these come through. So Anonymous said, wanted to post a note saying how much I appreciate the series. While I don't consider myself a beginner, it's very beneficial to have some of these topics brought up. I find myself learning something new or solidifying what I know. The chemistry between Holly and Ethan is very enjoyable, and it is a highlight of my week to listen to this.
Wow. So on the one hand, I guess we could go, Holly, well, your poor week if we're the highlight, but... On the other hand, we know what you're saying. Thank you very much for saying that. That really is really makes us happy. Now, the next comment, Holly, comes from Andreas, who's talking about something called DMVPN. So before you read this comment, I just wanted to set up for people what DMVPN is. So we have not talked about DMVPN on the show at all. And it, I kind of think of it as like a predecessor to SD-WAN. DMVPN is dynamic multi-point virtual private network, and it would be a way if you had a whole bunch of routers that you needed to be able to make VPN connections to one another, as opposed to what we're going to talk about today would just be like a one-to-one VPN tunnel. But you got a whole bunch of them, and they need to talk to each other. DMVPN was a way that it still exists, is a way that you could do that. And Cisco was big with DMVPN for, I don't know, call it 10, 15 years ago. I administered a DMVPN network that had like 3 hubs and, a bunch of spoke sites that were hanging out there plumbed into those 3 different hubs. But I don't know who's using it in 2025. So maybe that's a question for you out there in the audience. You guys using DMVPN in production? Is that still a thing that's a part of your network? Would love to know about that. packetpushers.net/follow-up and send Holly and I a note about your DMVPN. Anyway, Holly, Andreas has a comment tying back to tunnel versus transport mode in DMVPN.
Yeah. So Andrea said, a note on transport mode in IPsec tunnels. From recent NAT-T studies, DMVPN are actually the preferred tunnel mode. Didn't think about it then, but I guess it's private IP to private IP communication inside the DMVPN tunnel, so only the data needs to be encrypted. Not meant as a well, actually. More of an interesting side note. Are we making people nervous by calling out their well, actually?
I think we are.
Keep them coming. And then he gave us a link to an article saying the article is quite old, but the study book also mentioned that only transport mode should be used. And thought our IPsec episode was a great episode.
Okay, so on Andreas's note here, he made an early statement that might have been a little confusing. I think what his point was making, when you're using DMVPN and IPsec as part of your DMVPN tunnel stack, if you will, the preferred mode is transport mode. And then the link that he gave, that he says is quite old, is a Cisco.com link that digs into iOS documentation describing DMVPN connectivity and how you configure it. And in there, it is mentioned that transport mode is preferred. Okay. Long story short on this, because what he's responding to is the fact that, Holly, you and I were talking like, well, tunnel mode versus transport mode. And I think I made the point something along the lines of, I only have ever seen tunnel mode used in production. I haven't run into a use case for transport. Do you remember that?
Yes, I do.
Yeah, and I think that was your experience too. I know you haven't seen a lot of IPsec, but I think the use cases you've seen were tunnel mode, right?
Yeah.
Okay.
Yeah, exactly.
Okay, so that's what Andreas is responding to, and then he came across this, document that says, well, transport mode. Okay, we could dig into DMVPN, and Holly saw my notes on this point and was like, "Are we going to talk about all that?" Because I probably wrote way too many notes, but.
And I've never heard of DMVPN, so I was like, that might be a different episode for us to dive into that.
And maybe it should be, ways to connect networks across a wide area network of the past, DMVPN being a kind of a quirky and oddball solution that's fairly complicated to make go. But I will say this, because there is a larger point worth making. Andreas, what you found is a document that says you need transport mode and explains why. And in that documentation, it talks about being in the presence of a NAT-T environment where your DMVPN router is on the inside of a firewall, but needs to traverse that firewall that is connected to the internet. And so it's doing network address translation, NAT, from a private network to a public network. Now, Holly, you might remember we talked about the problems with NAT and IPsec. Do you remember that part of our conversation, episode 37? You're blinking.
Sure.
Okay.
Yep. I remember that we discussed it. Do I remember the details?
Do you remember what the problem was with NAT?
No. My brain is like a sink.
So the problem with IPsec and NAT is that part of the point of IPsec is to verify the packet didn't change from here to there. Yep. You can trust the integrity of this thing. No one's gotten in the middle and messed with it. Only if you run it through a firewall that NATs it, something got in the middle and messed with it. So therefore, integrity check's going to fail. And therefore, there's NAT-T, NAT traversal. That is a protocol that you can use to handle that situation so that it's going to be okay. Well, as I was digging through the article that Andreas raised, at this particular point in time, and this article goes back to 2012. It's 2025 now, so this is in computer years, ancient history. This version of iOS didn't support tunnel mode for that. It only supported transport mode for that if you were going to run it through NAT-T, if I understood that correctly. There's more detail we could get into, but long story short, I don't want to get into the nuances of the NAT-T and tunnel versus transport mode and DMVPN and why that matters, although I wrote lots of notes explaining it and how next hop resolution would break and various other things. And just to say, guys, if you're new to networking and you're digging into some complex protocol suite, there's nuance here and there are details. And just because your vendor says they support feature doesn't mean they support feature with all the bells and whistles that feature might have. So you might expect that because the vendor supports X, it does the thing. It might not, or it might do it partially, or it might have quirks in the code and be buggy. There's lots of bugs out there in the world where, especially with brand new code, where, there's a new feature that we're supporting now. Yay. And it's based on this new RFC that came out and we have customers that want this. And so we support it. And then you go to implement it and you're like, that crashed. That's bad. And you have to report bugs. Now, Holly, your work at Juniper, I'm sure bugs pop up in your life now and again. Yeah.
Yes. I'd say there's a difference between supported and recommended. And that's, you should check that out. Just because on a .1 release of code, something that you need is supported doesn't mean you should go to that. You should probably wait a couple of iterations and make sure that those new features have been tested and another customer has hopefully bumped into them and they've had the issue so you don't have to, and things like that, because, nothing's ever perfect.
Maybe you know the answer to this question too. I know Cisco has something called, they have different trains in their iOS release families. There's something that's the more bleeding edge train, and then they have what are called, or as they used to call it, the maintenance train. The maintenance train was like, this is mature, this is tested. We only put stuff in here because we've gone through the bleeding edge kind of process and we know it's all good now. So if you want like the most stable, predictable experience to working with a version of iOS, you use something in the maintenance train. Do you have anything like that in Juniper world?
We name it by like date of release. So there's like S1 or R1, and that's usually defining the first release. Based on the time. So it's, if you see anything that's got like R1 release, you should probably wait for R2, because that's R1 is usually the first release of that updated code.
Got it. Okay. So again, if you're new to networking, something to keep in mind, just because it comes from your vendor doesn't mean it's awesome necessarily. Everybody's writing code. Everybody's human. Not all the tests the vendor runs to make sure their code is good is going to replicate the environment you might have. You might create a situation that the vendor and the person writing that code didn't think of, and it breaks something. So yeah, be careful when putting new code into production, especially with the shiny new features.
Yeah.
Okay, Andreas. Anyway, thank you for submitting that. Super interesting and good to know of a use case where the vendor said, yeah, actually not tunnel mode, transport mode. Good to know, and good for all of us to keep those kind of things in mind as we're configuring stuff. Well, Holly, let's move into the meat of this podcast, which is, I only wrote a couple of words. I don't know why you're giving me that look right now. So it's
I don't know what look you're talking about. I'm just scrolling and scrolling and scrolling.
So okay, let me set this up for you guys. We wanted to follow up episode 37 in IPsec with some more details about, okay, so now you're actually doing it. You've got a couple of devices and you're going to build an IPsec tunnel between them. What does that look like? What are the things you need to think about? So the backstory is I spent hours in a lab with like a simple thing that I've done a zillion times, and it wasn't working and it wasn't working and it wasn't working. And long story short, it wasn't licensed, but I never got a warning. It never threw an error. It never told me there was a problem until I happened to type in the right command sequence that said, oh yeah, IPsec's not licensed on this box. IPsec is disabled. For real? So anyway, so there was that. And then I ended up standing up. That was on a couple of Arista EOS devices where it didn't happen that there was an IPsec license on these things. So, okay. So if you're a labber and you use Arista EOS, which they make available for free, I mean, it's they want you to use it. Just be aware there's a licensing component. I don't do a lot of Arista stuff, so I didn't even occur to me to think about licensing, especially for something as basic as IPsec. But anyway, I had done that work just to kind of remind me of all the things you need to think about when turning up IPsec in production. Because Holly, there are things. Now, if I remember right, you've done some of this stuff on the Juniper side, right? Stood up an IPsec tunnel?
I've done it once. I won't take full credit for it. I did have like our security specialist assisting me since it was my first IPsec tunnel. But it's funny because it should be pretty straightforward until you run into issues like you had. I do have a question. At what point did you think, did it like your issue transition from it's got to be a me thing to something's wrong with the boxes? Because I don't get to, like, I always blame myself first as the network engineer. Of course, it's got to be like a human error, right?
Well, so I struggle with that. I wasn't sure in that, like, I have a very strong Cisco background. I was a CCIE once upon a time. So, I mean, I know Cisco command lines really well. And I spent a lot of time with Juniper stuff. I know Juniper command lines less well compared to Cisco, but I can get around. And but Arista, I've only done a little bit of Arista work over the years, but Arista is fairly similar to Cisco. They feel, kind of the same when you're configuring them. And I pulled up the Arista documentation. I'm just walking through the documentation, and I kind of I know how this is supposed to work and all the pieces are here. This should be working. But I'm doubting myself because since I'm not that familiar with the Arista side, it's like I'm missing some little detail. I'm missing something. I scanned the doc too quick and I missed an important command, something. Sometimes there's things like, it doesn't work until you actually enable the feature. That's a thing.
Yep.
On some platforms where you get, you got to type, enable thus and so before that feature is actually, there for you and so on. It's like something like that. And long story short, it actually kind of was that. It was this license thing, but I didn't find it because I was thinking about licenses. I found it because working through the documentation where it said, okay, so once you've got the tunnel built and you type this show command, like it was show, I don't know, crypto IPsec SA or something like that, or show security connection SA, whatever their syntax was, I expected it to tell me something. And, and it just said not licensed. I'm like, what? Come on. And so at that point I knew, I was still doubting myself at that point though. I still was assuming it was me, until I got that feedback, back. A lot of times with things like this, you can get, it's a gray failure. It's like, okay, it's kind of working, but authentication is failing. And you can like look at logs and then go, oh, duh, I fat fingered something important or whatever. In this case, I always doubt myself just because I didn't know the platform. It's the first time I'd been there on the Arista boxes, and it didn't even pop in my head that licensing was a thing in that case, especially not on a lab image that they want people to be using and that they make accessible with very little friction. You can get a hold of that image and use it in your lab, which is why I'm using it. Anyway, all right. Anyways. So
30 years down the line, still thinks it's yourself. So I know that feeling's never going to go away. So I should get comfortable with it. So
no. It's not imposter syndrome. It's more born of the experience of so often it's just like, I'm missing some little detail because the details matter when you're configuring network devices to the point of madness at times. And so when things aren't working, and this tunnel wasn't coming up like at all. It wasn't like it was trying and failing. It wasn't like, it was just nothing. I'm running Wireshark against the interface, and it's like, there's not a packet related to IPsec going out over this interface. Nothing's happening at all. What am I doing wrong? It's a routing problem. I don't know what it is. It's a policy problem. I don't know. And I'm thinking it's me. Surely it's me. And when I find the right thing to type, then boop, 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 everything's going to be yay. No, in this case, it wasn't actually me.
When you got it up, what did it look like?
I never did get it up on the Arista side because of the licensing. What I actually did was swap out the Arista images that were in my lab for Cisco images, and then had to go through. It was basically an entirely different configuration, similarities, but more or less an entirely different set of configuration stanzas to make it work. And it came right up. So let's walk through, what all it looked like. So the first point I want to make, if you're bringing up, an IPsec tunnel between two vendor devices, what we've been getting at here, vendor nuance. So IPsec's a standard, right? Holly, we agree on that?
Yes.
Everybody can use this, and it's been around forever. And so, you can make two different devices that speak IPsec talk to each other, even if they're from different vendors. However, like a Juniper box and a Cisco box can definitely speak IPsec and make a tunnel with one another, 100%.
Yeah.
And a Palo Alto Networks box and a Juniper box can talk IPsec to one another, and so on. But just be aware that if you're in this world, there's a lot of details. And if you're talking Cisco to Cisco or Juniper to Juniper, it's just going to be easier. Certain things are just going to work that maybe don't work as obviously if you're talking Cisco to Juniper or Juniper to Palo Alto Networks or whatever it might be.
Yeah.
I just wanted to raise that point that because of how different vendors interpret the IPsec standards, little extensions or quirky things that they do, in their code to optimize IPsec or make it work the way they want it to work, it might not work with another box until you do some tweaks or kind of know how to massage the configurations on both sides so that they're going to be happy with one another. And again, I don't ask me how I know. I have scars. But is that, you've done the one IPsec. Was that Juniper to Juniper, or do you remember if it was Juniper to something else?
That was Juniper to Juniper, which is very simple because the commands are basically the same on both boxes.
Yeah.
So it's, if you can do one, you can hopefully do the other.
Yeah.
But yeah, I never thought about like the interoperability between two. I mean, it's always there with any protocol between different vendors. Sure, we all do it, but how do you do it is usually a little bit different.
And interoperability between vendors is an issue, whether you're talking IPsec or 15 other standard protocols, because there's usually enough flex in the way the standard was written that vendors can interpret things in different ways and still be compliant with the standard. But because they interpreted the standard in those different ways, you end up with a little quirk that means this feature, that function don't work quite right when you're trying to be interoperable between the vendors. Just something as a network engineer to be aware of if you're coming up in the world. And certainly that's true with IPsec. Top tip for IPsec multi-vendor configuration. A lot of times an engineer at one of the companies will have written, hey, if you're trying to make an IPsec connection between our box and this other box, here's how you do it. And they'll give you a little recipe to explain it. And so they'll help you. They'll save you some time. So look for that if that's something you're trying to do. I got a Juniper box and I'm trying to make it talk to a Palo Alto Networks firewall. There might be a recipe out there if you hit the right search terms that explain that to you. All right. Another point to make then is licensing. This is before we even get started. Make sure that if licensing is a concern on your box, and licensing seems to be everywhere these days, is your box licensed to run IPsec? That's a thing. Just make sure that it is, and off you go. And
a comment on the licensing is like some vendors enforce it and some vendors don't. So you might get an error saying you don't have the license, but you can still use the feature. That does happen. So just be aware that sometimes you might get the error, things could work. Sometimes you won't get the error and things don't work. So, just check for those.
Now that you said that, I'm wondering if there's someone from Arista that's going, Banks, Holly's exactly right about our box. We told you there was no license, but it doesn't mean it won't work. It'll still work. You must have screwed up the configuration. So if you're from Arista and you're hearing this, just ping me. You can find me and let me know, and I'll talk to you. We'll figure out what I'm doing wrong if that's the case. All right, now 22 minutes into this recording, Holly, let's talk about the tunnel configuration bits for IPsec. You ready?
No.
So the other part, dear listener, of this conversation is that Holly and I spent 10 minutes talking to each other about the weeks we've had. We've had weeks. So here we are trying to make our brains function as we talk through how to make two network devices, routers if you want, firewalls, whatever, talk IPsec to one another. So I'm going to focus more on routers. And the reason is if you're doing it in the lab and you're just standing up, a Cisco iOS device as your router, you can just do it all with text, and walking through it with the text will kind of help you understand the process a little more. If you do it on a firewall, a lot of times there's a GUI there where you can kind of click, 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 fill in the form, and a lot of magic just happens. And a lot of the IPsec details underneath are perhaps hidden away until you click through and go into an advanced configuration or something like that. For learning purposes, I'd recommend you spend some time with a router command line and try to figure it out. And if you do, there's a few kind of situations you might run into. You might run into a situation where you create a brand new tunnel interface, like tunnel 123, that is going to act as your interface that you see that's got IPsec applied to it, and that's where all the IPsec behavior is configured and so on. Other devices might take an existing interface that's already on the box, one of the routed links, and you apply an IPsec policy to it. So there's no separate tunnel interface, but this physical interface has got a tunnel policy applied so that certain packets that hit that interface match the policy and then are given the IPsec treatment before they're sent across the wire. I have not reviewed how Juniper does these, Holly. Do you remember enough about the one you did to recall what they do?
I think it was the second one where we linked the interface, and there was definitely some policies of, because not everything needs to traverse that IPsec tunnel. And I don't remember creating like a unique tunnel interface. That's not something that sounds familiar to me. Yeah, I'm like trying to pull up the config in the background to see what I actually did, because I'm curious now about how, because that tunnel interface, what do you mean by that? Like, because that's still going to be linked to a physical interface, right?
So here's another thing that as you begin digging through how to configure IPsec on various router platforms, you might run into IPsec over GRE, generic routing encapsulation, which is a different, yet another tunnel type. That can come up too, where the tunnel is GRE that's doing IPsec inside of it. GRE is not IPsec. You can do generic routing encapsulation as a separate thing. It's something we could talk about in a different podcast, I think. But you'll run into that where it's like, yeah, we're doing GRE and IPsec inside of the GRE, and so you end up with a GRE tunnel interface. Like DMVPN actually acts like that. It's multi-point GRE, and then there's IPsec, I believe, inside of the GRE. Could be the other way around. IPsec encapsulating GRE. No, I don't think so. I don't know. I didn't check that, and that's a side note. Just saying, there's different ways to do it, and depending on your vendor and what it is you're trying to configure, you may end up with different results. There's no one way that it gets implemented by the vendor. Keep the big picture in mind, right? Listen to episode 37. We're taking packets that match a certain criteria. We're going to encrypt them and then encapsulate them and send them out on the wire. And the two endpoints are the two encapsulation and decapsulation endpoints. That's the big picture. So these two devices are going to talk to each other. You might see a separate tunnel interface. You might be applying a policy to an existing interface. And now the two devices need to be able to talk to one another. They got to speak IPsec to one another. And IPsec is fussy. There's a lot of pickiness here. Because if you remember, we want to be able to prove that we're talking to who we think we're talking to, and no one's messed with data in between us and so on. There's all these components to the conversation that make IPsec, IP secure, IP security. We want these communications to be secured. And so IPsec endpoints have to speak to one another in a trustworthy way and in a way that they agree upon, or the conversation isn't going to flow. They'll be like, either I don't trust you, or you're not talking the encryption I want to, or the hash, you're not using the same hashing algorithm I want to use. And so then they won't talk. So you've got to be configuring the two devices so that there's compatibility on both ends. So let's just walk through at a high level what those things are. So I just mentioned encryption and then hashing algorithms. Some of them, encryption and hashing algorithms that are out there are old and you shouldn't use them anymore. But if you got some really old device like SHA-1 might be out there and MD5 might still be out there. And a lot of these have been broken where they're not, there's known vulnerabilities in those. So you want to do a little homework on why one encryption algorithm over another one. And also remember that the bigger generally speaking, the bigger the bit width, like this is a 4096-bit encryption algorithm, it might require more computing to accomplish that. It's more secure, like if it's a 2048-bit versus a 4096-bit. The 4096-bit might be more secure, but there's more math involved to get to that point. So how much traffic are you putting through this box, and does it have enough CPU, or does it have a dedicated chip just to do that encryption? These are the trade-offs that you're thinking about here. I wouldn't say, and what is the nature of the data that you're encrypting?
Yeah.
And how much of the data going through the tunnel is already encrypted because it's HTTPS, for example. What are we trying to protect here? What are the big secrets, that are going on? You got to think about all that stuff and come to an intelligent decision about what is the right set of encryption and hashing algorithms to use, and just make sure that you've got a set that are going to match on both sides, and both sides of the tunnel, both devices. And now, Holly, in the notes here, I mentioned ISACAMP and IPsec, phase 1 and phase 2. Do you remember the difference between the two?
No, I don't even remember discussing The ISACAMP, honestly.
Well, I think we were talking about Ike mostly.
Yes, Ike, yes.
Yes. Yeah. So ISACAMP or phase one, I have to look up what ISACAMP stands for as an abbreviation, but it basically, this is the first phase of the two devices standing up their IPsec connection between the two of them. This is the authentication phase. Who are you? Why do I trust you? How do I know that you are who you say you are? Well, that's going to have one set of encryption and hashing algorithms. And the idea is they need to protect the conversation they're having, to encrypt this, who are you and why should I trust you? You want to hide all of that. They also are going to be sharing something called a pre-shared key, in this, in this phase. The pre-shared key, it's kind of like a password. It's not really a password. I mean, it is a key. It's used it's used by the math to do encryption and decryption and to derive some of the other keys that are going to be used later on in the conversation. So it's not, I don't want us to think of it as a password because it does more. It's more important than just a password. It is called a key because it's a key. It's more critical for us to think about it that way.
I definitely think of PSKs in my head. I'm like, password, whatever, moving on.
Yeah, and well, you're not wrong because of how it's used in the sense that like we have a username, we type a password with it, boom, we're in. But from a standpoint of what's going on with IPsec, that key gets used to derive other keys, and therefore it's more than a password. It matters more.
The acronym stands for Internet Security Association and Key Management Protocol.
There you go. Okay. And IKE is Internet Key Exchange, which happens under ISACAMP. Thank you for looking that up. I appreciate that.
Sure.
Now, we use pre-shared keys as like the simple way for with pre-shared keys on both sides have to match, and then we can continue on with our conversation. But if we weren't using pre-shared keys, Holly, what might we use instead for this in this authentication phase?
Good question.
So certificates is the answer
certificates.
Here.
I was getting there. I was taking some time.
Well, certificates suck from a standpoint of complexity. They're awesome, but just for but then you got to manage certificates. You need a certificate authority. You got to manage the certificates, apply them to endpoint devices, and all of that. Whole certificate management, certificate authorities are a whole thing, but like more. I'll say robust, I don't know, enterprises will be using certificates for a lot of this sort of thing. But for you just learning IPsec and doing lab stuff, you're not going to be messing with certificates probably, depending on what you're, like if you're studying for a cert, what's required of you. You're just going to be using pre-shared keys. I just wanted to point out there's an alternative to pre-shared keys, certificates, PKI infrastructure. And but for our purposes today, we're not going to get into that.
It's on my list, to go through certificate management stuff. It's on the list of things I need to do.
It's fun, actually. You can build your own certificate authority. You can issue certificates from the certificate authority and use them, and it's a whole thing. And you can get into a lot with the OpenSSL libraries that are available on like Linux and so on. Yeah, it's super cool. It's really interesting. But it's a whole other way to think about things, and what's going on. And on the internet, certificate authorities are a big deal because that's how you get a certificate that shows up as that lock in your browser. And when you're doing HTTPS, there's a certificate in there. In fact, if you click on the lock or however your particular browser allows you to get to that information, you can read the cert. It'll tell you boom, boom, boom what it is. A key point I wanted to make here is the certificates are issued by a trusted certificate authority. Your browser has a library of known trusted certificate authorities that mean when you're presented with that certificate, it's not like Ethan wrote the certificate and so just trust me, the certificate's good. No, it came from a certificate authority that is a trusted source of sending certificates. That was all a side issue. Back to what these two endpoints on the IP, two IPsec routers that are trying to talk to each other need to agree on. So they got to agree on a pre-shared key is one of those things. And that's phase, I keep talking about phase one versus phase two. Phase one, who are you? Why should I trust you? When you pass that, okay, we agreed on our pre-shared key. We agreed on how to encrypt our communications about our pre-shared key and so on. And you get through all of that stuff. Now you move into phase 2. All right, I know who you are. I trust you. We've agreed how we're going to, encrypt some of our communications. Now let's talk about what we're going to talk about. That is, what kind of traffic are we going to put through the tunnel, and how are we going to protect that traffic that's moving through the tunnel? That's the phase 2 part of the tunnel setup. Is
the tunnel created in phase 1?
No.
Okay. So phase 2.
You have you have the beginnings of it. And like on a Cisco box, I know you can type show crypto ISACAMP SA. Or maybe it's Ike SA. I think it's Ike SA. Security Association, meaning, hey, we passed phase 1 and we know about each other. These are the things that we agreed on, these encryption and hashing algorithms, and so on. It'll give you a summary of what's happened. But that's not a tunnel yet. You don't have the ability to basically you've got 2 endpoints that trust each other and can talk about things, but we haven't actually built a tunnel or a transport mode conversation or anything else. That's what we're going to talk about next. But we got to get through the secret handshake, if you will. Yep. Okay, you gave me the secret handshake. I know I can trust you. Let's keep talking. Well, what are we going to keep talking about?
If you get stuck kind of at any point and you see that, for example, you've got this agreement, but the tunnel's not coming up, or maybe even before that, there's something wrong with that shared communication of how we're going to do things, for example. So if your tunnel's not coming up, you'd look at phase 1, maybe.
Yeah, and if you turn debug mode on any device that supports IPsec, there should be some way to log what's happening. It should tell you at what point the communications are breaking down. I tried to complete my ISACAMP phase 1 transaction, and we couldn't agree on. We couldn't find an encryption and hashing algorithm proposal that we could agree on, so we gave up. Or pre-shared key doesn't match, so we gave up. That should be logged, or you should see phase 1 success, meaning that thumbs up, authentication phase. That phase 1 component was successful. Now we're in phase 2, but we can't agree on what to talk about, or we can't agree how to have the conversation. And there should be logs that indicate what's going on in that. And I'll tell you, if you get into digging through IPsec logs because the tunnel's not coming up, there's a lot of detail and there's a lot of jargon and abbreviations and nuance where it can be really helpful if you remember what phase 1 is, what phase 2 is, and you kind of know what IP address belongs to whom, and you know which networks are supposed to be talking to each other, because a lot of that stuff gets logged, and the details really matter as to why something isn't working. Things like, one that'll happen is, I'm talking about proposals, that 2 sides are going to propose some pairing of encryption and hashing algorithms to one another. Well, if they don't each have a proposal that matches somewhere in their proposal lists, it'll fail. And so you're looking at this, debug log that's got a bunch of like HMAC 256, whatever, like, you got to kind of have an awareness of what that stuff is, because it matters as you're digging through and you're like, oh, on router B, I need to add to the proposal list this specific one that'll match in the proposal list on router A, and we should be good. You need to kind of have that much awareness and don't just get overwhelmed by the crazy jargon and abbreviations and nuance that are in those logs. And there can be a lot of things because there's a lot of little steps that go back and forth that we haven't documented here, that can fill up a log with a lot of detail. That's like, okay, the first 90 lines I actually don't care about because line 91 says phase 1 succeeded. And you're like, okay, so why I don't care about the rest of that. Show me the failed part, but you gotta know what you're looking at, and it can be troublesome, the first time you do it. So anyway, so we got through phase one again, and we're talking through phase two. Now we're going through kind of the same conversation we had with phase one, only we're not talking about authentication. Now we're talking about how are we going to talk about what we want to talk about. So first of all, what do we want to talk about? And do you know what I mean by what do we want to talk about as an IPsec pair?
I'm assuming you meaning, well, cool, there's a tunnel, but how are we going to get the actual data now across? And are we going to...
Well, from a standpoint of what we want to talk about, that is, so what you just said is definitely part of the conversation, but the part I'm getting at with what we want to talk about is what IP networks talking to what IP networks are we going to put through the tunnel? And both sides need to say, yeah, 10.1.1.0 and 10.2.2.0 are going to be talking through this tunnel. Yep. We need to agree on that. Now, here's an asterisk and a caveat. Depending on what you're configuring, you may build a policy that defines exactly that. These two networks exactly are the networks that are going to talk about, or this network is going to talk to these 10 networks, whatever your list looks like. But you can configure tunnels so that it's like, I want everything to go through the tunnel. And I don't care about the nuances of which network talks to whom. If you're going across this link, you're in the IPsec tunnel. Done. That is another way to configure things. For most production environments, what you are setting up is a tunnel that is specific. I need, and the scenario is very often like either merger and acquisition or someone you're partnering with, and you guys need on your private networks to exchange information with one another. I need this network, this subnet on my network to talk to this other subnet or these other 3 subnets on this other network. And so you're going to build a policy that defines exactly that. And you need to have that policy match on both sides. Well, match. They need to be mirror images of each other. Do you know does that make sense to you?
Yes, I think so. Because if they matched, you'd have, for example, the exact same IP address on both sides, which doesn't make sense. So it would be, like you said, mirror images. So if this is .1 on this side, it probably should be .2 on the other. So
it could be that for the tunnel peering, and then for the networks that need to talk to each other, your source networks on the one side will be your destination networks on the other side as you build out, whether it's an access list or whatever the language is that the device wants you to use to communicate to it. Hey, these are the networks I want to talk to each other. An access list is a pretty common way to do it.
Yeah.
So mirror image. Source becomes destination on the opposite side.
And it seems, that seems very logical until what I said earlier. Oh, well, you're dealing with 2 of the same vendor boxes, so you can just copy and paste the CLI and change the stuff that should be mirroring each other, but you forget to change one of them, and then it breaks.
Yep, exactly right. Yep, I did. Actually, I went through that this morning as I was completing my lab. I'm going through, okay, here's my router 1 config, now my router 2 config. It's going to be like this, but I just got to flip my tunnel source and destination addresses. I got to flip, and yeah, I don't think I made a mistake, but I was looking very carefully. Okay, make sure I get all the bits that should be flipped around so that I'm right here. Okay, so that's what we're going to talk about. We got to agree on those networks, and we got to agree on how we're going to have the conversation about those networks. Are we going to tunnel? Or are we going to do transport mode? What are the encryption and hashing algorithms that we're going to use? What is the lifetime of this connection going to be? When you agree on these things, you form something called an IPsec SA, or Security Association. Well, how long does the Security Association live? This is a highly secured thing. Seems like it shouldn't live forever, because what if something bad's going on, or I don't trust the other side anymore? At some point, we want that SA to die and have to be renegotiated so that we still know we're good here and we still trust each other. So there's a lifetime that you'll measure on both sides. You could measure it in time, length of time, or bytes, the number of bytes that actually go through the tunnel. Oh, we've had 100 billion bytes went through the tunnel. Okay, I want you to kill it and renegotiate. Let's make sure that we still want to trust each other. Another thing that'll come up here is something called dead peer detection. Does that happen to ring a bell with you? It's part of the IPsec standard, so you might have run into it.
Yeah. So, I mean, it's pretty self-explanatory. You are detecting.
It does what it says on the tin. Yeah.
Dead peer. Yeah. Which, for the most part, you need to figure out, is the something on the other side still up?
Exactly right. Exactly. Which is common, not just in IPsec, but I mean, it's common through a bunch of different routing protocols. Like we were talking about OSPF and hellos and the hello timer interval, hellos being used as a way to detect that your OSPF neighbor is still up. And lots of protocols have some function like this. In IPsec, the standard way, which happens to be an RFC 3706, because you needed to know that, is dead peer detection. And there's a couple of different ways you can do keep alives for dead peer detection. It's called a keep alive mechanism. Mm-hmm. Is the tunnel up? I'm sending a keep alive message to make sure that, which is a more generic term, but I'm sending a keep alive message to make sure that again, the other side is still alive. There's a couple of ways you could do it. There's the hello ACK method. I'm going to send you a hello. And Holly's going to say, I got your hello. I acknowledge it. I ACK it, ACK. Mm-hmm. The other method would be, I call it the hello method. I send you a hello, so you know I'm alive. You send me a hello. I know you're alive. And we keep track of each other that way rather than, hello and acknowledgement. But you don't have to use dead peer detection. You don't have to use IPsec dead peer detection. Yeah, it's a standard. It's there. It's available. A lot of vendors give you that option. But some vendors will give you some other method to do dead peer detection or to make sure that the other side is still alive that scales better. Hello ACK and sending hellos all the time. What if you got 50,000 peers out there? You got some huge SD-WAN with, full mesh and you got a bazillion tunnels you're trying to actually make sure that they're still up and alive. You can burn a lot of CPU just keeping track of each other. And so some vendors have their own method that they might recommend to use because it just scales better if you got a very high number of peers. So these are all things that the two sides of the tunnel need to agree on. And again, a lot of this is worth mentioning just because if you have things that they don't agree on, the tunnel won't come up. And then you're into troubleshooting. Well, why won't the tunnel come up? Why did things fail? And having this expectation in your mind of what all needs to be agreed upon, should help you with troubleshooting so that we should be agreeing on tunnel mode. And you might see an entry like, one side's configured for transport. Or, Holly, like you were saying, we didn't get the mirror imaging right on the networks that we're supposed to talk about. Whoops, we blew that. Or, the encryption and hashing proposal in my list, there wasn't anything for them to agree on in the two lists. Oops, I gotta update that and so on. So, but once you get through all of that stuff, the tunnel should be up. But there's yet more stuff that we need to think about now that's really aside from IPsec itself, but is still important. And to me, the biggest one to be thinking about now is routing. These are routing devices. We need to think about our routing. Why does routing matter?
Well, you can send stuff from A to B, but we need to figure out where it's going, how it's getting there outside of just those two endpoints, that destination and source. I mean, there's the rest of your network. It's got an endpoint. Exactly.
You've got a couple of problems that you're trying to solve. One is, from a routing perspective, you need to make sure the two tunnel endpoints, the two devices that are forming the IPsec connection between themselves, can see each other. So that could be a routing thing. And this can be a bigger deal in your lab environment where, like on the internet, it's going to work. There's going to be routes pointing everywhere. The two tunnel endpoints are probably going to be able to see each other without you having to do any routing stuff. But in your lab, maybe not. You don't have an internet in your lab unless you got a really awesome lab. But you might have to, like in my lab, I created like a central router that didn't do anything but pretend to be the internet just so I could replicate it. I didn't like directly connect the two IPsec routers together on a link. I had another router in between them on completely separate link networks, point-to-point networks, just so that you kind of got that piece in play. But anyway, you need to make sure that the tunnel endpoints can see each other. Then you need to make sure that the IPsec routers themselves can talk to the networks they're passing traffic for. I'm trying to encrypt 10.1.1.1 on the one side. Well, can router A talk to 10.1.1? I'm trying to talk to 10.2.2 on the other side. Well, can router B talk to 10.2.2.2? Or whatever the networks are that you're trying to pass through. So you got to make sure your routing is good there as well. And then the last thing that's kind of routing related is you got to make sure that your policy has been set up so that the traffic that needs to be encrypted, put through the IPsec tunnel, goes through the IPsec tunnel, and it doesn't just get dumped out the default interface pointed to the internet or something like that. And that's usually a policy thing more than an IP route thing. But as I recall, I have seen some configurations where it's like, yeah, and the way they make this do is you put a route statement in that points this traffic that's destined for the IPsec tunnel to the tunnel interface, maybe. Mm-hmm. That could be a way that it's done.
Yeah.
Going back to your experience, was there, depending on what you were configuring, you might not have had to do any magic routing because it might have all been there for you.
I don't think we did do any. There was definitely some policies and some traffic steering that was configured to say if this is coming from this device, send it through the tunnel. But it was nothing super complex. To test it, we just plugged in some like host devices into the router and made sure one host can ping the other host. So you know that it's getting from A to B and everything in between is working.
So, and I think in most production environments, most enterprise networks that a lot of our audience will be interacting with, that's going to be the case. It's probably it's going to be fine. And once you've got the IPsec policy itself defined, that's the only quote unquote routing magic that needs to happen. The device will take care of it from there. But for those of us that are doing labs, you can't assume all that, all the endpoints can talk to each other. What's that?
I'm about to disappear. Give me a second.
Okay.
It's rebooting.
Oh, no.
I literally I clicked not now, and then I just saw all of my windows start to close. Let me move to my phone. Hold on.
IT strikes again.
I'll be back.
Hey, listener. And if you're like, why did he just say, hey, listener? We were talking about routing. We were. And what you don't know that happened because it all got edited out is Holly's laptop was taken over by the corporate IT overlords that rebooted it right in the middle of our recording. So we had like this 12, 13 minute gap where we're like, is it going to come back? And then we got it back. So Holly, to conclude our routing part of the conversation, for people that are in production environments, I think by and large, your routing is probably going to be okay as is, but something to keep in the back of your head. And then if you're in a lab and you're struggling to get the tunnel endpoints to come up and see each other and begin doing IPsec things, or you're struggling to get traffic through the tunnel or these kind of things, check your routing. Walk it through router by router, device by device, and make sure that everybody knows how to get to everybody else that they should. Another thing to verify in your routing, again, if you're in a lab environment, the two networks that you're trying to protect with IPsec that are on either end, you should not be able to ping between those two. You want to make sure that the only way they can connect is when you go through the IPsec tunnel once you've built it. That's another good, lab point to remember. So you got to think through your routing is my point, especially key on in that lab environment for you. So much more we could say about routing, but for sake of time, we won't, because let's keep this under an hour, Holly. Let's try. Two bonus topics I wanted to raise. One is maximum transmission unit size, MTU. Now, we did talk about this in an episode on tunneling. Do you remember much about that part of our conversation?
MTU size is critical because I just see that it always causes problems. And like if your MTU size doesn't match on both sides, most of like the troubleshooting notes that I've seen in everything, regardless of protocol, is first step, make sure your MTU size matches.
Yep.
Because if it doesn't, then you're going to have dropped packets, you're going to have other issues.
With the issue with tunneling is that when you put a packet inside of another packet, that additional packet adds overhead. It makes the packet bigger. You start out with a packet that's X big. Now you put an IPsec wrapper around it. Now it's bigger. You've got more stuff there. And so you'll get a lot of guidance in your from your vendor, you should get some guidance on what to set your maximum transmission unit size for an interface, so that when the IPsec encapsulation happens, you've got enough room to handle that without making the packet so big that it exceeds the maximum transmission unit size. Just wanted to point that out, that that's a thing. What you're trying to avoid fragmentation. You may not even be in your environment allowed to do fragmentation, all depending on what policies have been configured, and so on. So just be aware that whenever you're tunneling, including IPsec, MTU is a thing, then you may need to configure IPsec to be something smaller than the default physical interface side to leave room for that IPsec wrapper that's going to go around the packet. Bonus topic. I'm not going to get into any more detail than that. And you're like, well, what should the MTU size be for IPsec and so on? It depends is the answer. And again, if you're looking at your vendor's guidance on that, they'll probably have a recommended value for you. Another bonus topic, and the final bonus topic I wanted to raise, is just to mention NAT again. Just remember that in production environments, it's possible that you'll have your IPsec router behind some kind of a device performing network address translation. And the most common scenario would be, that I can think of, would be an IPsec router that's inside your network on your private network. It's going through a firewall that is connected to the public internet. And so that IPsec traffic's got to flow through the firewall that's performing NAT before it gets to the other side. When you're dealing with network address translation in IPsec, you got to remember that NAT will by default break IPsec, which we've talked about before. And therefore you might have to do some different configuration and look up NAT-T, NAT-T, NAT traversal, and begin to think through how you might support your IPsec using NAT-T or some other guidance that your vendor might recommend if you have that situation of an IPsec router inside a firewall that's a gateway to the public internet and therefore is performing NAT. I would recommend that if given an option, from a network engineering perspective, don't have your IPsec router inside of the firewall. Have it next to the firewall maybe. Or maybe the firewall should be the IPsec router. I mean, that's a very common role for a firewall to play, is to be your IPsec device. That simplifies your design. It makes your troubleshooting less complicated. You're not worried about like, oh, is my tunnel broken because it's flowing through the firewall and I got to look at that firewall and see why things are broken. That just complicates your life. So have the two devices be in parallel to one another, perhaps, or have the firewall itself, and this would be my ideal circumstance, be your endpoint for your IPsec transaction is what I'd recommend that you do, given a choice. But as all network engineers know, sometimes you don't have a choice and you got to do things the hard way. And that's why things like NAT-T and other sorts of workarounds exist. Well, okay, Holly, you asked for this series on IPsec. So did you get out of this what you were looking for?
I definitely did. I came into this, like I mentioned a couple of times, like having configured an IPsec tunnel, but never actually diving into everything we've discussed today and in the previous episode. So it's really given me more visibility into the tunnel. But I've really enjoyed it because now I can go and set up a tunnel and, as you've mentioned, like actually understand the logs, and when something's gone wrong, have that understanding of what that process should be so that I can then go back and fix whatever's gone wrong, instead of just typing commands and saying, yay, it worked, with little to no understanding of why.
Yeah. It's worth pointing out that there are other ways to do VPNs. IPsec is one way, and I mentioned that earlier. There's other protocols that can be used and techniques and so on. It's also worth pointing out that a lot of client VPNs, that is, you install a VPN client on someone's laptop so that they can talk to VPN at home. It's using the same technology, but it might feel different in how you administrate it. But functionally, it's more or less the same thing that's happening under the hood, just different ways you get that same job done. So it's not going to feel like I'm making two routers talk to each other about specific networks. Yeah, but it's you're not, but it's more or less the same thing. Like you might be configuring your client VPN with a list of networks that you want to go through the client VPN, and you as the administrator configure that. And when the client VPN connects, it gets that list of all the networks that should go through the tunnel. Hey, that's actually part of your security proposal thing. Or your network list. What are we going to talk about? Ends up getting used in phase 2. That's what's actually happening under the hood. So just, take what you've learned about IPsec and try to see how a vendor's actually implementing it and understand what's going on underneath the hood, behind the clicky boxes and the drop-down lists and all that stuff. There's real stuff based on standards probably that's happening under the hood. And you can kind of, if you know what you're looking at, you'd be like, oh, they're doing this and that. I get it. I know what's happening. And so on. It makes you, when you begin to understand this stuff at a deeper level, it feels like you just like achievement unlocked. You can peek behind the curtain. You actually know what's going on rather than, and that's the difference between you being a network admin and being an engineer, where you really know the guts of what's happening under the hood. And that's kind of a big deal. Okay, well, thank you for listening to us chat about IPsec. And if you got any comments, questions, actually feedback, if I got some detail wrong or something, send it all to packetpushers.net/follow-up. Holly and I read every single one, and we're trying to include as many of them into follow-up shows as we can. That feedback comes right into our private Slack channel, and we really appreciate it if you do that. Again, packetpushers.net/follow-up. Guys, like, share, and subscribe. This is a big deal. Let other people know about NS for networking. A lot of the feedback that Holly and I have gotten have come from long-time Packet Pushers listeners, which is awesome. We are very pleased that you guys are listening, but we want the younger people to be listening to this too. So share this show with your younger colleagues. You got some junior engineer that just started, or someone at the help desk that's kind of interested in networking maybe, and you think they might be the next up-and-comer into the networking team. Send them NS for networking. That would be awesome. We would really, really, really appreciate that. And last but not least, just remember that networking isn't hard. Other people figured it out, so you can too.